Okay, let's dive right into this. Welcome, everyone, to our complete Zero to Hero explainer on multi-agent systems. Artificial intelligence is evolving faster than literally ever before, and we're right in the middle of a massive paradigm shift. For years, the whole industry's focus was basically on building a single monolithic model. One giant brain capable of tackling any task you throw its way. But as the complexity of the problems we're trying to solve just keeps growing, it's becoming crystal clear that a lone genius, no matter how brilliant they are, can usually be outmatched by a well-coordinated team of specialists. And honestly, that is the absolute magic of multi-agent AI. Here's our roadmap for today's explainer. We'll be covering the rise of agentic AI, single versus multi-agent AI, architectures and workflow orchestration, how AI agents communicate, leading multi-agent AI frameworks, and finally, real-world autonomous collaboration. All right, let's get into it. Starting with Section 1, the rise of agentic AI. We are officially moving way past the days of just relying on a single AI chatbot to handle every single request from start to finish.
To really wrap your head around this, try thinking of a modern digital assistant not as one giant entity, but as a highly coordinated team of specialists. Imagine you have a navigation agent finding your best routes, a music agent curating your playlists, a calendar agent making sure you don't double book, and shopping or chat agents handling their own specific little domains. So instead of one AI trying to do literally everything, the tasks get divided up intelligently. This creates a really powerful collaborative intelligence system. It's actually a lot like how human teams operate inside large organizations. Except, these agents never need to clock out or take a coffee break. They're just constantly passing messages, using specific tools, sharing memory, and coordinating their actions to seamlessly manage whatever workflow you throw at them.
Moving on to Section 2, single versus multi-agent AI. So the crucial point here is understanding exactly where the old approach hits its limit and where this new modular approach begins. Let's break down the core differences. A single agent system, where one AI handles everything, is still really great for basic linear scripts. It has a much simpler architecture, but it pretty quickly struggles with large-scale workflows or complex multi-step automation. On the flip side, multi-agent systems give you multiple specialized roles. They provide the redundancy, the error checking, and the dynamic problem solving that you absolutely need for real-world automation. Think about it. If a problem is too broad, a generalized single agent is going to perform pretty poorly. A multi-agent setup distributes that load, letting you deploy highly specialized agents that can collaborate, reason together, and even double-check each other's work before they ever deliver a final result. That brings us to Section 3, architectures and workflow orchestration. Now, obviously, to harness this massive amount of collaborative power, you can't just let these AI teams run wild, right? They need rigorous structure and automated management. And that is exactly where agent orchestration comes into play. You can think of this as the management layer. Instead of a human having to sit there and manually control every single step, the orchestration system lets the agents automatically decide the task order, select the exact right tools or APIs for the job, handle any errors or retries, and essentially execute complex workflows completely autonomously. It is literally how systems take massive, overwhelming challenges and logically divide them up into manageable subproblems for different AI personas. But how are these teams actually organized under the hood? Well, there are four main structures we usually see. First, you have a flat structure, where all the agents operate completely independently as equals. This is awesome for decentralized swarms. Then there's the hierarchical structure, which operates pretty much exactly like a corporate ladder, where you have supervisor agents delegating tasks down to execution agents. Next up is holonic, which is super fascinating. Basically, agents are grouped into nested subteams. This means a tiny team of agents can actually act as a single, unified unit within an even larger system. And finally, organizational or network structures. These form dynamic, flexible clusters based entirely on whatever the immediate situational needs happen to be. Section 4, how AI agents communicate. Let's peel back the layers here and look at the underlying mechanics. Because you might be wondering, how exactly do these autonomous agents actually talk to each other? Well, communication really sits at the absolute core of an artificial society. It's the foundation. Communication is what enables both competition and cooperation. And that shared communication drives coordination, which then forms the organization, which ultimately allows for meaningful interaction with the outside environment. It's basically the lifeblood that makes all these advanced reasoning workflows possible in the first place. One classic protocol agents use to actually delegate this work is called the Contract Net Protocol, or CNP, and it functions a lot like a sealed auction. So a manager agent announces a task by sending out a call for proposals. The contractor agents on the network evaluate if they actually have the skills and the bandwidth to do it, and then they reply with either a proposal to do the work or a rejection. The manager reviews all the incoming bids, accepts the absolute best one, and then that chosen contractor gets to work, eventually reporting back when the job is done or if it needs to cancel. It's just a remarkably efficient way to dynamically allocate tasks across a big distributed network. But there's a bit of a catch, right? Especially when we start talking about physical robots. Standard agent communication languages, things like QML, they are highly semantic and fantastic for that high-level negotiation we just talked about. But they're heavy. They carry a massive overhead. If you have a physical search drone that suddenly needs to send high-frequency video or low-level telemetry, a standard communication language will just completely choke the system. That is exactly why researchers developed a dual-tier backchannel architecture. What this does is keep that high-level language for the complex negotiations, but it opens up highly efficient, flexible backchannels specifically for streaming raw data. It really is a best-of-both-worlds solution. All right, Section 5, Leading Multi-Agent AI Frameworks. Let's shift this explainer from all this highly technical theory straight into the developer sandbox. It's time to actually look at the code abstractions. So I want you to think about this for a second. If you were to sit down at your computer today to build one of these autonomous teams, where would you even start? What tools are the professionals actually using to build these things? To answer that, we're looking at some fresh data from Alice Labs, and this is based on over 18 real-world production deployments across financial services, media, and the public sector in 2026. So to be clear, this isn't just theoretical sandbox stuff. This is what is running in actual production right now. Now, what's really interesting about this matrix is just how hyper-specialized these frameworks have become. If you're an engineer and you need explicit control, complex stateful workflows, and maybe a human in the loop for debugging, LangGraph from the LangChain ecosystem is absolutely your go-to. Now, if you just want to spin up a really fast role-based prototype where you define, say, a researcher, a writer, and a reviewer, Crew AI is going to be your best bet for sure. Working inside a massive enterprise that runs heavily on Microsoft infrastructure? Well, Semantic Kernel is built exactly for that. And if your agents primarily need to reason over your own private index data, Llama Indexed is the top pick. The golden rule here is simply to identify your dominant constraint and pick the framework that matches it. And finally, Section 6, Real-World Autonomous Collaboration. Let's ground everything we've talked about today by showcasing exactly where these autonomous architectures are out there actually saving lives. Take the healthcare sector, for example. Look at this quote from ML6 regarding their AI tumor board concept. They explain that agents specialized in diagnostics, vital sign monitoring, patient history retrieval, and treatment planning can actually work together to help clinicians in real time. This isn't just one lone AI model trying to guess a complex diagnosis. It is a fully orchestrated multi-agent framework. You've got one agent monitoring the vitals, another analyzing the scans, and another digging through the patient's history. They synchronize their findings to drastically reduce the cognitive load on human doctors, ensuring decisions are consistent and heavily evidence-backed in really high-stakes scenarios. We're also seeing this incredible technology in disaster relief. These systems utilize multi-agent reinforcement learning to deploy whole fleets of search and rescue drones. These agents use deep neural networks to process decentralized logistics in completely unpredictable, dynamic environments. And what's really amazing is that beyond just raw brute force speed, their reward functions are mathematically weighted to balance that task efficiency against programmed ethical metrics, things like fairness, transparency, and reliability. So they are constantly optimizing their search grids while strictly adhering to those ethical guidelines. Which brings us to the ultimate question. The era of the single monolithic AI is clearly making way for these dynamic, specialized, and highly orchestrated AI societies. The tools are here, the frameworks are production tested, and the real-world value is just undeniable. So, as challenges grow too complex for any single AI, are you ready to stop relying on a lone genius and start building an autonomous team? Thank you so much for joining me for this explainer. Keep exploring, and I will catch you in the next one.